So hello my colleagues, and I hope everyone is well. So I have to make some videos here for chapter 10, and we're going to talk about risk, okay? And unfortunately this chapter's got a ton of equations they're not that bad, but we'll go over them. So here's some of the notation that's going to be used in this chapter, okay? And we'll start going over some of the ideas in here about how risk is priced with expected return, standard deviation, variance, okay? So don't let these equations get to you. If you have any problems with these equations, just let me know. And, I will just send you solutions, okay? So we look at the history of risk, and we go back 92 years. And Standard & Poor's is a portfolio constructed it says 90 U.S. stocks up to 1957, and then they added 500 after that, all right? And there's small stocks, okay? And there's a world portfolio, and there's corporate bonds, and treasury bills, which really are default, risk-free, right? Because they're not going to default. So anyway, we look at these graphs here, okay? And you can obviously see obviously, if you want to make money, the value of $100 invested in 1925 in stocks, bonds, or bills, the red here is the highest, and you've got to have be in small stocks. But what you're going to find out is that's the most risky, okay? That's probably the most risky. And here's the S&P 500. But this is the real, look at the difference. It's a factor of 10, right? Almost $6 million if you would have invested $100 in 1925. Okay, and you can clearly see, and here's inflation, right? Here's inflation, the consumer price index, and here's T-bills. You can obviously see the difference between if you invest in T-bills and small stocks. You'll never get rich in T-bills. All right, so what I want to do, you can see the different time horizons here, right? After 1 year, after 5 years, after 10 years, after 20 years, right? Value of $1,000 invested in different assets for different time horizons. So if you were to put $100 in 1925, you would have seen how it would have grown, right? Depending on the year you invested it. You would have $1,000 by now, right? After 20 years, so by 1945. So all right, so we got to talk about probability distributions, and these are going to be, we're going to talk about different measures of risk and return here. All right, this is important, so we got to talk about that. And so again, we're going to discuss ugly probability distributions. I know if you didn't take a probability class, this is new to you. So a probability distribution is simply a graph that provides the probability of every possible discrete state. Okay, so here's the current stock price, and here's the stock price in 1 year. Here's the different return. You can see the return is 40%, right? The difference here, right? 10%, minus 20%. But here's the probabilities of that happening. And you should be aware that the probability always has to add up to what? 100%, right? So you should be aware of that. So that's the first thing you should always have to know, that this has always got to add up to 100%, all right? So we can show this as a graph, right? A histogram. Here's 25, 25, and 50. Like here's the 50, and here's the 25, and the 25. Okay? And if you look here at this graph, this is the expected return, right? Kind of like if you want to make a continuous curve. So you kind of expect that your continuous return is going to be right here, or 10%, right? Right, because that's kind of in the middle. Everyone see that? So this is the likelihood of these particular outcomes. All right, so the expected return, once we have these probability distributions of returns, we can compute what's known as the expected return, right? And the expected return is a function of the probability of each thing happening. And we're going to find that there's another equation for, I guess, expected return later, or average return. So we calculate the expected or mean return, and on the average payoff expected, but it has probabilities associated with it. So there's a couple different terms for this. So this is a weighted average of the possible returns where the weights will correspond to the probabilities. So this is the equation. So all you simply do is take the sum of each probability times the return, okay? And that'll give you the expected return. So from the previous example we saw before, here's the expected return. Here's the 25%, 50%, and 25%. All right, multiplied by the expected return for each one of those, minus 20%, 10%, and 40%. So your expected return is 10%, just as we saw in that graph, right? Just as we saw in that graph. And there's your answer. So that's not a bad equation. So that's pretty simple. Okay, so now we got to talk about the variance. And so we got to discuss the risk of a probability distribution. And basically the variance and standard deviation are going to help us find the risk. Once you have the variance, you can get the standard deviation. So here we are with variance and standard deviation. The variance is the expected squared deviation from the mean. Okay, so that's the variance. And the standard deviation is just the square root of the variance. So the standard deviation will be easy. It's just that we've got to get the variance. So here's the two equations we're going to talk about. And again, there'll be another variation of these equations in this chapter later. Okay? So the variance is the expected return of the return minus the expected return of the mean, right? So here it is. If we write this out, it's the sum of the probability times the return minus, basically this is the mean, right? This is the mean here, even though they're writing it this way, but this is the mean, and you got to square this difference. So you subtract these two, square it, multiply by the probability, add them up, and that'll give you the variance. And then once we get this variance, we can just take the square root of that and get the standard deviation. All right, so there's an important point here, right? There's an important point. If the return is risk-free and never deviates from its mean, the variance is 0. Otherwise, the variance increases with the magnitude of the deviations from the mean. So basically, the real important thing to know is the variance is a measure of how spread out the distribution of the return is. Okay, so in this example that we previously saw, which I'll highlight here, the variance was 0.045. If you notice how they're subtracting the mean from each return here and then squaring it. Everyone see how they're squaring it? And then they multiply it by the associated probability, and that'll give us the variance. Once we get that variance, which is this here, we just take the square root, and that gives us the standard deviation. So getting the standard deviation is probably the easy part. It's just getting doing the variance portion. Now again, you could do this all in Excel. If you are so inclined, open up Excel and put all this program Excel to do this. So the standard deviation is known as the volatility, right? So this is the volatility. And basically the standard deviation is the one most commonly used. Okay? So here's a nice example of, they show the expected return and volatility in example 10.1. And again, here's the expected return. Okay, so this is just for one return. So they just do this for one here, right? So it's equally likely to have a 45% return or 25 minus 25% return. Now the secret here is it says equally likely. So they should you have to know that means 50%, right? 50%, okay? So look here, 50% times 0.45 plus 50% times minus 0.25, and that gives you 10%. To compute the volatility, we first determine the variance. So now once we got the expected return, we put that in here, right? And you can see they're putting that 10% in there. You see that? And we get the variance, again, by multiplying the probabilities times this term. So then the volatility, or standard deviation, is just the square root of 0.1225, and you can see them doing that here. So this is the volatility. Now, the higher the volatility or standard deviation, the more riskier the stock. Okay. So note that both AMC and BFI have the same expected return. However, the returns for AMC are more spread out than those for BFI. The high returns are higher and the low returns are lower, as shown by the histogram here. So AMC has a higher variance. You can see that, right? And volatility than BMI. So this is more riskier. So you can see this guy's more risky. And you can tell by the standard deviation. Okay? The higher the standard deviation, that's all you got to look at is the standard deviation. So while both stocks have the same expected return, AMC's return has the highest variance and standard deviation. All right, so now what we've got to do is look at historical returns. Now we're going to look back. We don't have to deal with probabilities in this case because it's happened already. So we're going to look at different ways of calculating a return, different ways of calculating variance, and different ways of calculating standard deviation. So this will be the second way we look at this equation. And the magical words are historical because it happened already. So the probability is obviously 100%, right? Because it already happened. All right, so of all the possible returns, the realized return, which I'll click on here, is the return that actually occurs over a particular time period, right? We realized it. It happened already. Is the return that actually occurs over a particular time period in the past. How do we measure the realized return for a stock? Suppose you invest in a stock on day T for this price. If the stock pays this dividend on that date and you sell the stock at this price, then your realized return is here, which has got two components, right? You see these two components? See the right side of this equal sign here? So here's the dividend yield on what you paid, and here's the capital gain on the increase or decrease for that matter in the stock price. So that is, as we discussed in Chapter 9, the realized return is the total return we earn from dividends and capital gains, okay? So this is a simple equation. It's just addition and division. And again, this is different than the expected return we saw previously. All right, now, if you want to get the annual return, if you want to annualize this and say, well, what did I really get over a year? You got to take each quarter. Let's say, you notice how they give you each return for 3 months, each quarterly return. And if you know the quarterly returns from like each 3-month period, you just can take each quarter and multiply them together. And this is like the compounded return, okay? So you can notice basically you have each quarter's return and you multiply it there. And here is another example. Here's Microsoft stock, and you basically have here the date and different dates and different prices and different dividend yields. And here's the different returns. This is the return from here to here. You'll notice it's negative, and here's the return from here to here. Okay. So what were the realized annual returns for Microsoft stock in 2004 and 2008? So 2004, it was 0.08. Okay. So you can see they got an 8-cent dividend on the share here. And here is the stock price in 2004. So this is from December 31st to August 23rd. So you notice you lost money. And basically you do the rest of the returns in the table. Okay, so here's a 3-month period. And here's another basically period here. All right, 1.186 and 0.9755. So you can clearly see they're adding 1 to each of these numbers. Each of these numbers is having 1 added to it, which is why this is less than 1. So you can see 1.1186, and again, this is less than 1 because this is negative. So you subtract 1 and you get the 2004 return here, and then the 2008 return, you follow a similar pattern here, right? So you got 1, 2, 3, 4, 5, right? There's 5 periods from here to here for 2008. 1, 2, 3, 4, 5. And you'll notice you lost a lot of money in 2008 for Microsoft. So they're showing you how to do the realized return for the S&P, Microsoft, and T-bills, right? Here's the S&P, right? And here's the T-bills, and here's Microsoft. So you can continually do this. If you have trouble with any of the math here, just let me know, and I'll do some examples for you here, okay? But again, all you got to do is take each period and multiply it by you notice how there's every 3-month period here. Okay. All right. So I'll knock off here, and then I'll pick up on part 2 here.